mentioned, so we will be covering the new features introduced as part of GlobalProtect 6.2 as part of today's presentation. So we already saw the agenda with the topics that are going to be covered, or at a high level, the features. So I'll be covering each one of them as part of today's presentation. So we'll first look at the enhanced split tunnel configuration. So I'm sure everybody is familiar with the split tunnel configuration, where we actually classify traffic that takes the direct path to the internet and traffic that goes through the tunnel with the split tunnel configurations. So now we have some limitations with respect to the split tunnel configuration. Basically, the configuration for your deployments, you're unable to meet the mobile users' access and performance needs because of the existing split tunnel domain and access route limitation and constraints. Like example, you want to exclude bandwidth heavy voice and video traffic, like maybe Microsoft Office 365 domains and a set of IP addresses, maybe Zoom, WebEx, and webcast traffic, all of these things, right? So you are not able to include all of these domains, maybe due to a compliance requirement such as a PCI requirement or a payment card industry requirement, maybe because of the scale limits that we have with respect to the number of domains and IP addresses that we can add as part of the split tunnel configuration. And maybe because of this, you're unable to facilitate access to sensitive resources which are whitelisted to be accessed only over the tunnel via the split tunnel configuration. So the admins are having to spend lengthy cycles as a result of these things to manage and optimize the split tunnel configuration on a regular basis. So even after all the optimization, the deployments are unable to meet the business needs because of the limitations that I spoke of earlier. And this could lead to some amount of distress, right? So we have some enhancement as part of the enhanced split tunnel configuration. So with these split tunnel configuration, the existing limit that we have in terms of the IP addresses and the domains will be actually increased to 1,000 from the current limit of 200 that we have. And then the admin will manage the split tunnel configuration via a file that can be hosted on a publicly accessible server. So basically, the gateway should be able to access the server where that particular file is hosted. And then the split tunnel configuration file URL will be configured in the gateway in the split tunnel configuration part. And the GlobalProtect will download the public key from the portal and also the split tunnel configuration file from the server, right? And the existing split tunnel configuration will be supported as well. That's not going to go away. And the admin will be able to configure the split tunnel via the file or the traditional way of configuring the split tunnel. So basically with this, we have removed the limit of 200, and you can configure the split tunnel configuration onto a file, a signed file that you can host in a publicly accessible location, such that the gateway can access this. And all of this configuration will be downloaded from the portal to the agent, and the agent will download the file from the portal that is mentioned, and the split tunnel configuration will be applied. So this is the enhancement that we have as part of the split tunnel configuration. Next, we have some HIP remediation enhancements. So we have the HIP process remediation as a feature that we are introducing. So you can actually have maybe a lack of the remediation capabilities, like you cannot remediate host when there are some custom check failures. And the employees will lose their productivity because of the HIP check failures that are happening. So to overcome this, what we have done is we have a new HIP remediation process where actually you can have a script to remediate the HIP issues. whenever a GlobalProtect endpoint, fails, or one or more process checks will fail, and the endpoint can be recovered from that particular condition of the hip check failure. Suppose you create a script, right, that will run on the endpoint whenever a hip check fails. Then such a process check or registry or p checklist fail, you can have a script to remediate that. After that, the endpoint will run the remediation script, and the GlobalProtect app will actually resubmit the hip report, and the issue that was there with respect to the hip check will be remediated, and basically the hip check failure is remediated, and the users will be allowed to access the network or the resources without having to wait for the next hourly hip check, for the hip check update to get pushed to the endpoint, and this whole delay or cause for a productivity reduction in terms of the employee concerns. Those can be solved with this particular solution. So for this, actually, you would need to create a hip remediation script and deploy it to your endpoints using the MDM software that you probably are using in your organizations. And then you can actually enable the new hip remediation process timeout, and to indicate the amount of time you want to give the remediation process to complete. After the timeout, the GlobalProtect app will resubmit the hip report, and you will be actually remediated of that hip issue, or the end user's system will be remediated of the hip check issue that they are observing. So the customers will write and manage the script as per their remediation needs. And then the whole remediation process will kick in, and GlobalProtect will resubmit the hip report, and the users can connect back to the network post the remediation has been taken care of via this process. Okay, so we have one more hip enhancement, like exceptions for the patch management. Now, there are some cases where actually there is a continuous patch update that is actually pushed to the endpoints. Like, say, example, a Windows Defender, right? It has a frequent security update, like maybe through one of the patches. Okay, and it will be a high severity package like a SEV2 package. Now, even though the patch is present on the endpoints, these updates cause OPSWAT report, and this patch will be missing in the GlobalProtect HIP evaluation. So hence the GlobalProtect will report a missing patch as part of the HIP report, right? So this will result in the customer security policy taking effect, and the user will be blocked or will be limited in terms of the access to the network. Now, the customers blocking the traffic from the GP users with the missing, high severity patches face like daily GP blocking issues, because these updates can come in multiple times a day, right? Sometimes the customers or the IT admin needs to take a week or two before they roll out these patches or updates to the endpoints, like say Windows or Mac OS endpoints, right? So in absence of a grace period capability for these security patches in the HIP, the remote users will constantly run into access issues due to the HIP policy enforcement. Now, we have come up with, like I was talking about, this slide is talking about the Windows Defender patch, where actually frequent security patches are being updated, like the patch that is highlighted here. And the customer's traffic will be blocked from accessing the resources for the GlobalProtect users, where actually we have the patches missing because these patches come in very frequently, and the users could see this issue on a daily basis. So we have introduced a host information profile patch management grace period, where you can actually configure the exception for the particular patch number and maybe exclude it for a day or you can exclude it from the HIP report, forever as such. So that way you can have, the patches that are frequently getting updated by configuring that grace period, so that the users will be allowed to connect to the network, and the problem of the frequent patch update, and then the mismatch and the global protect users being denied access to the network, that one will be avoided. Okay, so next we have the conditional connect method for GlobalProtect. Now, we have a lack of flexibility in terms of the connect methods. Like the users are nowadays working in hybrid environments, so they could be connecting from home. Sometimes they could be connecting from the office. Maybe they can connect from a coffee shop as well. So you may want to have some flexibility with respect to the connect method based on where the users are actually connecting from. Without having any disruption in terms of the productivity as such, right? So to improve this user experience, we can actually have the conditional connect setting, so that the GlobalProtect can have a dynamically changing connect method based on whether the user is in the internal network, or he's working from a remote location. So it is useful in environments where actually users connect to GlobalProtect at all times, when they are in the office, in the always on mode, but they don't require to have GlobalProtect connectivity when they are away from the office, except maybe when they are accessing the private apps within the organization. So with Conditional Connect, GlobalProtect actually uses the internal host detection to determine whether the user is on the internal network, and then it will set the connect method accordingly. So for us to deploy this feature, the conditional connect must be configured to the endpoint transparently in the Windows registry or the Mac OS plist. And you must also enable the internal host detection for this particular feature to work, and configure the endpoints to use the on-demand connect method. Okay, so as I said, again, just to summarize, so GlobalProtect actually does the portal authentication, and the GlobalProtect portal configuration is received. We have the internal host detection method enabled. So if within the office internal network is detected, HIP report is sent to the internal gateway for the security policy enforcement, right? Now, with the conditional connect method based on the network type, you have GlobalProtect performing the portal authentication. The portal configuration receives the internal host portal configuration is received by the host, and the internal host detection is enabled. While at home, the reverse DNS lookup will fail as it is not detected as an internal host. And the GlobalProtect changes to the on-demand connect method and waits for the user to initiate the connection. So when the user has to access private apps, he will initiate the connection to connect to the Prisma access. He could otherwise, not connect to the GlobalProtect as such. So this is the flexibility that is provided by the conditional connect method. Okay, so then we have the extension of the user session. Now we all have users working. Now it may not be a 9 to 5 session. It could be extended beyond the actual stipulated working hours. Now at this point of time, if there is actually a timeout of the remote user session, it could lead to productivity disruptions, like maybe the sudden loss of access to corporate resources. Users could be frustrated because of that. Users could be unaware of the disconnection because of a poor UX. And then there will be an increased, admin overhead, because the users will reach out to the admin and create help desk tickets. which will add to the overhead of the management, will add to the overhead of the management team as such. Right. So in an attempt to improve this user experience, we have the user session extension feature. So the GlobalProtect actually will solve this problem of the user session getting expired. So the admin will configure how long before actually the session times out, if the end user should be notified that their session is going to be timed out. Like say example that the admin would want to notify the users 30 minutes before the session timeout. Like he configures a session from 9 a.m. to 5 p.m. But half an hour before the session ends, he will notify the user that his session is going to expire. Now in the on-demand connectivity, the end user will initiate the GlobalProtect connection to the gateway. And then upon the successful login with always on connectivity, he will be connected to the GlobalProtect. Then upon successful authentication, he will obtain the configuration. And when the end user needs to be notified prior to the session timeout, even that configuration will be actually obtained. This will help the end user like actually support an agent who regularly uses cloud applications to fill in reports on customer calls and these kind of job roles. This feature would definitely help. Like maybe if now the the admin has set a 30 minutes prior to the session timeout as a notification period, the GlobalProtect will notify to the end user that, hey, your session is going to end in 30 minutes. And the end user, upon viewing the notification, he's able to save the work that he's currently doing, or maybe take necessary steps, ahead of the session timeout. That way his user experience is improved. In addition to the login lifetime timeout, the admin can notify to the end users upon the admin initiated logout and the inactivity timeouts as well, right? So just to, summarize the whole thing. So admin configures when and what notification message to send to the user prior to the session timeout, like how many minutes before the session timeouts, and what is the message that the user should see at that point of time. The GlobalProtect agent connects to the gateway after successful authentication, and the user will be notified of the session expiring, like whatever minutes was configured by the admin before the session timeout actually happens. User is able to save the work, and he can also opt to extend the session for the duration that he desires. So the user now is connected to the US gateway, like US West gateway in this diagram that you can see in the second diagram here. Then he receives a session notification timeout, and then the user extends the session after the reauth and stays connected to the US gateway. So there is no disruption in this case. So when he extends the timeout, he doesn't lose a connectivity. Before the timeout happens, he does a reauth and is able to stay connected on the network. Okay. So then we look at the explicit proxy connectivity in the GlobalProtect. Now, this is for the always on internet security that we want to achieve. So as we all know, the explicit proxy, we do not have a GlobalProtect connectivity for the explicit proxy. So with 6.2, we are introducing explicit proxy connectivity in the GlobalProtect itself. So we are introducing a new mode called the Proxy Mode, and we also have a tunnel and proxy mode. We'll look into the details of that. Okay, so Prisma Access, as we all know, adds explicit proxy connectivity through the GlobalProtect as part of the 6.2 feature. So if organizations have proxy-based architectures, they could benefit from the ZTNA 2.0 while connecting with maybe third-party VPN agents as well with the introduction of this feature. So we are actually introducing the proxy mode in the GlobalProtect agent. So GlobalProtect in the proxy mode can be used for internet security. Like, as you can see in the diagram here, so any traffic that goes towards the internet and the SaaS application is sent in the proxy mode, which means that it will go through the proxy. Any traffic that is excluded from the proxy will take the tunnel mode or will get tunneled to the private apps. So access to the private apps is provided through the tunnel mode, and any other traffic that is not included in the tunnel mode or the proxy mode goes through the direct internet connectivity or the excluded traffic. So this is what we have introduced as part of the 6.2. Now let's look at the proxy mode. So in the proxy mode, we make use of GlobalProtect and connect to the proxy. So the proxy will do the continuous trust verification as well as the continuous security inspection using all of the features like the advanced URL filtering, threat prevention, SaaS security, DNS, advanced wildfire, DLP, etc. So there is a continuous security inspection and a continuous trust verification, which means that ZTNA 2.0 for any traffic that goes towards the internet to access anything on the internet or maybe the internet hosted SaaS applications. So this is one of the use case for the proxy mode. So we can also coexist in the proxy mode with third-party VPNs. So the access to the private apps in the data center could go via the third-party VPN, via the IPsec or TLS tunnel. Whereas in the for the case of the internet access, we can have the continuous security and trust inspection via the proxy mode, so that all traffic that is towards the internet or the SaaS applications is protected by the explicit proxy. Okay, so we also have a hybrid mode where we can actually use both the tunnel or the tunnel mode for the traffic as well as the proxy mode for some of the traffic. Now, in this deployment, we have the tunnel mode for access to the private applications. The private applications are hosted in the data center, connected via the ZTNA connector or the service connection. So the private app access security is provided by these deployments, and you connect to these private apps via the GlobalProtect full tunnel mode. Whereas for the internet-based traffic, we actually have the proxy mode of connectivity, and all traffic towards the internet or the SaaS applications hosted in the internet is inspected by the explicit proxy. So this is the proxy mode as such for the internet-based traffic and the tunnel mode for the private apps. So this is a hybrid mode of deployment with both the proxy mode as well as the tunnel mode. So this is another use case where we have the data center that is protected by the NG firewall, and we have all the internet-based traffic going via the explicit proxy or the Prisma access. So this is again a tunnel and proxy mode. So we have an IPsec tunnel or a TLS tunnel that connects to the private apps that are hosted in the data center. That could be protected by the NGFW. And then we have the proxy mode, where all the internet-bound traffic, including the internet-hosted SaaS applications, access to these is provided via the explicit proxy. So the ZTNA 2.0 and the continuous security inspection and trust verification is provided by Prisma Access as part of this solution. Okay, so that's a brief about all the features that are introduced as part of 6.2 GlobalProtect. So I'll open up for any of the questions that we can take at this point of time.